The question says a bar magnet of length 14 cm is placed in a magnetic meridian with its north pole pointing towards the geographic north pole. A neutral point is obtained at a distance of 18 cm from the center of the magnet. If BH is equal to 0.4 g, the magnetic moment of the magnet is. So what the question is saying that this is a bar magnet, and then there is some neutral object that is placed over here, which is at a distance of 18 cm from the magnet, and now there will be some magnetic field acting on this neutral particle, which will be equal to B naught in this direction. And now this B horizontal that is given us to be 2 B naught sine theta. So let's analyze. So now let's assume some conventions that we are going to use over here. Let capital M be the magnetic moment, small m be the power of the magnet, theta be the angle that is made by B naught with the horizontal, and B naught be the magnetic flux density. So when we solve the vectors of the vector addition of the magnetic moment, we get B to be equal to 2 B naught sine theta, which is equal to 2 into mu naught upon 4 pi r square into sine theta, that is length, 7 upon hypotenuse, that is r. On substituting the values, we get 0.4 into 10 raised to minus 4 to be equal to 2 into 10 raised to minus 7 into m into 7 divided by r square, that is 7 square plus 18 square whole raised to power 3 by 2 into 10 raised to power 4. So therefore power comes out to be 4 into 10 raised to minus 2 into 373 raised to 3 by 2 divided by 14. Now magnetic moment is equal to magnetic power into length, that is 14. Now this should be in centimeter, that is 14 upon 100. So therefore we have magnetic moment is equal to 4 into 10 raised to minus 2 into 373 raised to 3 by 2 divided by 14 into 14 upon 100. So therefore magnetic moment now comes out to be 2.88 joules per Tesla.